Hello mga kamasters, hello mga kaskemiling. We will learn today how the human reproduction began. Hundreds of millions of sperm versus a single egg cell. The sperm cells are streamlined and designed for this purpose. A long tail to help them move, lots of mitochondria to power the movement, genetic information to pass on, and enzymatic proteins to get into the egg cell. The proteins are stored in a cap at the front of the sperm known as an acrosome. This is the part that first contacts the egg. The tail is called a flagellum, and it uses the energy made by the mitochondria to move the sperm forward. Flagella use a lot of energy, so they're kept dormant until sperm enter the vagina. Sperm are haploid. They contain one set of 23 chromosomes. They are created by the cellular division process known as meiosis, which creates formed sperms from a single germ cell. They're also very small, only about 50 long. Sperm are ejaculated in semen, a basic fluid with a pH of about 7.4. The sperm target is the egg. Since it is so much bigger than sperm, the egg is the source of cytosol and organelles, particularly mitochondria. For the future zygote, unlike sperm, the egg has not completed meiosis. It's stuck in the metaphase stage 2 of division. This means that the egg is haploid but with sister chromatids still attached to each other. Also, unlike sperm, the meiotic division to create eggs, oogenesis, only makes one viable egg. The egg is covered in a thick outer coating known as the zona pellucida, a layer of carbohydrate-covered proteins that surrounds the plasma membrane. The zona pellucida helps protect the egg and is responsible for mediating the initial meeting of the sperm and the egg. Cortical granules filled with enzymes line the inside of the cell membrane and will help make sure that only one sperm can fertilize the egg. The setting. Egg and sperm travel in opposite directions to meet most often, in the fallopian tubes. During ovulation, ovaries release an egg into one of the fallopian tubes, and the egg proceeds down the tube towards the uterus, which is being prepared for possible implantation. Part of this preparation involves elevated levels of estrogen and luteinizing hormone or LH. LH triggers the ovaries to release the egg, while higher blood estrogen levels stimulate the vaginal membrane to secrete glycogen, which is then metabolized to lactate. This lowers vaginal pH to as low as 3.8, creating an acidic environment hostile to pathogens like the ones that cause sexually transmitted infections. However, this environment can also be toxic to sperm, though the semen, or a basic fluid, can buffer the vaginal acidity to preserve sperm cells. As the semen mixes with the vaginal secretions, the pH settles at a point that is not harmful for sperm, and this new environment is a trigger to activate sperm flagella and increase sperm's motility. Only 1 in 1 million sperm that are ejaculated into the vagina will reach the site of fertilization. Estrogen also relaxes the cervix, causes cervical mucus to become watery and more alkaline, and stimulates uterine contractions, all of which help sperm penetrate and navigate the female reproductive system. Relaxing the cervix allows sperm to pass from the vagina into the uterus and reduces a potential physical barrier. Cervical mucus may prevent sperm from passing into the uterus, but during ovulation, when the egg is released from the ovaries, the mucus gets thinner and lower in pH. These changes make the mucus a great transport medium for the sperm and help the sperm continue traveling. The uterine contractions actually help to push sperm toward the correct fallopian tube, and recent studies have suggested that these constructions are more responsible for sperm movement than the sperm's own propulsion mechanisms. So we can see the progress of sperm is really influenced by where in the menstrual cycle the female is. The closer to ovulation, the easier it is for sperm to pass. Scientists think this may be to conserve energy and resources. If the female isn't ovulating, then there's no target for the sperm, so it makes more sense to focus on protection against pathogens. The vagina and uterus are very susceptible to infection, so the body has to balance on fine line between protecting these areas and allowing sperm to come through. Embryogenesis. The first 8 weeks of development after fertilization is an incredibly complicated process. It's amazing that in 8 weeks we're transforming from a single form cell to an organism with a multi-level body plan. The circulatory, excretory, and neurologic systems all begin to develop during this stage. Luckily, like with many complex biological concepts, fertilization can be broken down into smaller, simpler ideas. The big idea of embryogenesis is going from a single cell to a ball of cells to a set of tubes. Let's start at the very beginning. Step 1. A zygote is the single cell formed when an egg and a sperm cell fuse. The fusion is known as fertilization. Step 2. The first 12 to 24 hours after a zygote is formed are spent in cleavage, very rapid cell division. The zygote's first priority is dividing to make lots of new cells, so its first new days are spent in rapid mitotic division. With each round of division, it doubles in cell number, so the cell number is increasing at an exponential rate. This division is taking place so quickly that the cells don't have time to grow. So the 32 cell stage, known as the Marula, is the same size as the zygote. At this point, the zona pellucida, a protective membrane of glycoproteins that had surrounded the egg cell, is still intact, which also limits how big it can grow. Blastulation and cell differentiation. Step 3. During blastulation, the mass of cells forms a hollow ball. In step 4, cells begin and differentiate and form cavities. Around day 4, cells continue to divide, but they also begin to differentiate and develop more specific forms and functions. When a cell differentiates, it moves down a certain path toward being a specific type of cell, example, an ear cell or a kidney cell. And this process, 99% of the time, only goes in one direction. Two layers develop, an outer shell layer known as the trophoblast and an inner collection of cells called the inner cell mass. Rather than being arranged in a solid sphere of cells, the inner cell mass is pushed off to one side of the sphere formed by the trophoblast. The rest of the fluid-filled cavity is called blastocoel, and the whole setup resembles a snow globe. The outer trophoblast will develop into structures that help the growing embryo implant in the mother's uterus. The inner cell's mass will continue to differentiate, and parts of it will eventually become the embryo. So it is sometimes called the embryoblast, or the suffix blast means to make. This is also time when the zona pellucida begins to disappear, allowing the ball of cells, now called a blastocyst, to grow and change shape. In non-mammal animals, the term for the stage is blastola, but we still stick with terms that apply to human development for the purposes of this discussion. At this point, cells in the inner cell mass are pluripotent, meaning they can eventually turn into the cells of any body tissue like the muscle, brain, bone, etc. During the second week, these cells differentiate further into the epiblast and the hypoblast, which are the two layers of the bilaminar disc. The disc is a flat slice across the developing sphere and splits the environment into two cavities. The hypoblast is the layer facing the blastocoil, while the epiblast is on the outer side. Let's imagine each of these layers as a flat balloon. The balloons expand to fill the space and become the two new cavities, the primitive yolk sac on the side of the hypoblast and the amniotic cavity on the side of epiblast. The amniotic cavity will eventually surround the fetus. Fetal development, the first trimester. Fetal development begins soon after conception. Find out how your baby grows and develops during the first trimester. You're pregnant! Congratulations! You'll undoubtedly spend the months ahead wondering how your baby is growing and developing. What does your baby look like? How big is he or she? When will you feel the first kick? Fetal development typically follows a predictable course. Find out what happens during the first trimester by checking out this weekly counter of events. Keep in mind that measurements are approximate. Weeks 1 and 2, getting ready. It might seem strange, but you're not actually pregnant the first week or two of the time allotted to your pregnancy. Yes, you read that correctly. Weeks 3, fertilization. The sperm and egg unite in one of your fallopian tubes to form a one-coiled entity called a zygote. If more than one egg is released and fertilized, or if the fertilized egg splits into two, you might have multiple zygotes. We have in weeks 4, the implantation, the rapidly dividing ball of cells, now known as blastocysts, has begun to burrow into the uterine lining. This process is called implantation. In weeks 5, hormone levels increase. The 5th week of pregnancy or the 3rd week after conception, the levels of HCG hormone produced by the blastocyst quickly increase the signals your ovaries to stop releasing eggs and produce more estrogen and progesterone. Increased levels of these hormones stop your menstrual period. Week 6, the neural tube closes. Growth is rapid this week. Just 4 weeks after conception, the neural tube along your baby's back is closing. The baby's brain and spinal cord will develop from the neural tube. The heart and other organs also are starting to form, and the heart begins to beat. Baby's head develops in week 7, and in week 8, baby's nose forms. And in week 9, baby toes appear, and in week 10, baby's elbows bend. Week 11, baby's genitals develop. Week 12, baby's fingernails form. Mga kamasters, mga kaskemeling, for a pregnant woman, feeling a new life developing inside her body is an amazing experience, even though she may not always feel her best at some points along the way. Pregnancy can be different from woman to woman, and even for the same mother from one pregnancy to the next. Some symptoms of pregnancy last for several weeks or months, while other discomforts are temporary or don't affect all women. Remember mga kamasters, mga kaskemeling, pregnancy is a long 10-month journey according to Dr. Draylon Bunch. Bye-bye!